today what we're going to be doing is we're going to first talk a little bit about notes. You don't need to go get your binders. We'll talk about that in a moment. And through that, we get to kind of review some of the things that we've been talking about all class long, but we haven't actually formalized them in writing it down. Because in our first unit, A, you did a lot of writing, but B, also because a lot of what you learn in programming languages, it's easier to learn first as a whole by just doing, and then after that, we could summarize it in notes. And with that, I'm not going to always give you a set of fully done notes, but I thought this time around, since the first unit was so notes heavy, I would actually just give it to you with everything filled in, and then we can just talk about a few things that I may have said in passing, but now can be formalized in some notes for this particular unit. This is also all the main notes that you need for the units, all the concepts, and then of course being able to program effectively in Reebor as well. So we'll first start with that. You can then keep this with the rest of your notes, especially if you're considering doing comp sci IB. Some of the content in here, of course, will be needed for IB in 3 years anyways. What's commitment? Okay, we're missing a good chunk of people, that's fine. Okay, so let's first talk a little bit about this particular document. I'm actually also going to pull it up on the screen once I find the correct keyboard, since I left it over here. And then we're just going to go through some of these notes just so that we can formalize them into what they all mean. And then after that, we're going to talk a little bit about what you'll be doing for the next 5 days, which is your summative project, which also means that in 2 weeks, you're also going to have your unit exam, quotation marks, for this course, and we're almost done this next module. Which means we'll get started with our next one right in time for the Christmas break. Please load and not crash. Okay, so first and foremost, the first thing on your notes is the integrated development environment. So these are the different sections of the editor that we are using. And almost every programming environment has many of these items in it. But the one thing that I really want to first impart when it comes to integrated development environments is that you don't have to use them to program. So it is ultimately there for convenience, but you can program with just a notepad and some terminal or command line commands, and you'd be able to program anything from Java to Python to C++ without the use of an integrated development environment. The value of having an integrated development environment is that it has all of these different things. So it has the source code editor. So we've talked about how the source code editor is like this section where we're actually writing our code. We then have the compiler, which is what takes the actual code and turns it into machine executable code. So stuff that the computer can then use to run the program. So in Reebor's world, our play button is our run button. So this is kind of our compile and run button. When you hit run, the reason why there's that delay is because it first uploads your code to our server, which is actually right over there, and then it processes it, and then it downloads the results back to your computer and it runs it. So that's why it takes a little bit, because it compiles the program which means that it takes the code, checks if it's all right, and then after that runs the program. Which is why, if there's something wrong in your program, it doesn't actually run at all. It first just gives you an error, which is actually not typically what the Python programming language does. So we have a source code editor, a compiler. An interpreter is very similar to a compiler, but it functions differently. So this is something that you will need to go through more in grade 11 and 12 or in IB, but there is a difference between the two. And this I'll also say is not on your exam, but like you need to know like where the interpreter / compiler is, but not what the main differences are. And the main differences is it comes down to speed. So what I mean by that is that Java is a compiled language, which means that when I make my source code, Java will then first compile the code by testing all the code, seeing if everything is syntactically correct so that there's no missing like tabs or missing colons or anything like that. And then after that, it spits out a .jar file, or it could even just spit out a .class file. But it spits out files that are now executable. So these ones are the ones, if Mr. Zhang could spell executable, these are the ones that run, not your file that contains your code, but the actual files that are made after compilation. Whereas something like Python, which is what we're actually coding in, is that once you actually do your code, so whatever the code is, what will happen is that it will run the actual code file. So it will run whatever file that is happening. It doesn't actually make a new file. So that means that when the code file is run in Python, it checks every single line as it runs to see if it works. And therefore, like you can keep running the program until there is, like you forgot to do an indentation, and then it will stop at that point, saying that it only got that far. This just allows you to write code quickly, but you also have that danger of, if you're making a really big program, well, it has to check every single line for errors every single time it runs. So it will eventually get slower than if I program it in Java, where when it runs the executable file, it is no longer checking for code errors, because it already did the check when it compiled these brand new files. These files would not exist unless the code was correct. So it compiles the new file, and that new file is error-free. So it can run faster, because there are no checks. In Python, which is an interpreted language, the source code is interpreted while it's run, and it is then checked for errors during the runtime, not during the actual, like beforehand, the compilation time. So that's the difference, but that also means that depending on the language, whether it is a compile or an interpreted language, there's often a run that will either say compile and run, or it'll just say run. But it's going to either compile and run or run an interpreted file based on the programming language, not necessarily on the IDE. That being said, there are like programs like Java, like their development environments often has a compile button and a compile and run button if all you need to do is compile a particular file. So that's just a small distinction that you don't have to worry about for your exam, but because in your notes it does have that it could be an compiler or an interpreter, that both of them generally point to the exact same thing. And the other thing to note is that it does give an example that if you compile a program for Windows, that's how you make .exe files. So the exe files that then Windows can run. Exe is short for executable. Okay. So with that, like I said, as long as in Reebor's world you can say that this run button is the compiler and the interpreter, that's all you really need to know. Okay, other things is that the debugger. So this we've seen in Reebor all the time, where if there was an error somewhere and you hit run, then Actually, I don't know if that will give it an error. That may not. Okay, it did give it an error. What will happen then is that it will give you an error. Oftentimes, it will give you direction on where. So here it says that it was like num2. Because of the fact that this interface doesn't easily give line numbers, sometimes it's hard to find exactly where. But most debuggers give you a line number so that you can go and see where exactly that error occurred. I think actually if I turn off syntax highlighting in Reebor, it often does, okay, clearly not in this example, but it often does give you what line the error is found, so you can go there and make fixes. So that is kind of what a lot of IDEs have. And once again, if you don't have an IDE and you're running the program anyways, what ends up happening is that the error just appears when you're running. So this is ultimately just a convenience, not a mandatory to use an IDE, but it is important for your exam to know the different parts of them and where they are. So the debugger in Reebor's world is that pop-up that appears whenever there is an error in our code. Then we see the actual pop-up appear. And that would be the debugger. And it's important to read them so that they actually tell you kind of what could be wrong. So this num2, oh, perhaps you misspelled a word or forgot to define a function or a variable. So I didn't actually define it because I accidentally have 2 equals, which means something else. It means compare. So I just need to go ahead and fix that, and then it runs just fine. If I didn't have an IDE, I'd have to scan through and find out where the error is. Okay. So like I said, we've already kind of gone through that before, so that was a little bit of a review, which strategically I'm doing after a long break, so that it hopefully stays in your long-term memory a little bit better. We also talked a little bit about errors, so this is it formalized again. There's 2 different types. There's syntax errors, and there's logical errors. So the syntax errors, these are the ones that the debuggers find really easily because there's something wrong with your code's grammar. Whether that's you forgot a colon, you forgot an indentation, or you indented too much. It's basically any of those grammatical errors that prevent the program from actually running properly. So these ones debuggers pick up really easily. You can generally go find where they are and then fix them. And then be on your merry way. Normally, when you're just starting to learn a language, syntax errors are the common error because you're not used to writing like all the indentations, the colons, and so on and so forth. But as you progress, then logical errors are the things that happen. This is like last class when we talked about the world where I showed in class where the actual dimensions of that rectangle could change dimensions. And some of the first programs that we wrote for it still got Reebor to go all the way around, but he didn't stop at the final spot he was supposed to. That would be a logical error. The program fully runs, it's able to run, but it doesn't do what it's supposed to do. So this is also things like when you're doing harvest, maybe you did a program where you did it harvest 1 row and you tried to repeat it 6 times and you realized it went into a circle. That would be another example of a logical error. It runs, but it doesn't run correctly or with the anticipated outcome. And then from there, debugging is a process to fix it. And I've said this already in class before, where when it comes to debugging, you are the expert. You have to figure out what is wrong and fix it. Because in an area outside of the classroom, when you're working as a programmer, you can't just go to someone else to be like, what's wrong with my code all the time. You do have to be able to find the problems yourself, which is why the debugger is so useful, because it tells you, at least gives you information about what is wrong with the program. Okay, scroll down. Scroll down. Or crash. Crashing works too. This is why I recommend only having 3 tabs open in Chrome, because sometimes 4 can cause some problems. But if we turn over the page, what's on the next page? The next page has a little bit more about debugging, so it just gives an example. Really? I did not expect it to crash this hard, but apparently it is. You can tell it's crashing because if you look at my processor graph, it's not moving. So that's generally an indicator that something horrible is going on. Okay, so unfortunately I can't show the rest of it right now, but on the next page, you just have an example of the debugger with an error code. I think it gives you like an indentation error so that it gives you an idea of what the error is. Oh, did it move? Oh, is it moving again?
Yeah.
Maybe. Scroll. Scroll. Or just crash. That's okay. Crashing is fine too. I left it on over the break. I probably should have turned it off to give it a rest, but
Robin's open like 15 days.
I know. But I also like using them in front of you to show that it's not only you guys that have problems with it sometimes. It is a thing that can happen. I'm going to switch to the also equally really weird right now. Let's see if I can get it to work. Oh, hey, this one's not working. Okay. So we're going to go here just so I can continue on with our instructions. That just means I got to get a few things switched over. Okay, so coming back from here, we got to here. So this is an example. It's just a screenshot of the indentation error, and that's not indented. And then it kind of gives you an idea if it's one of the 4-ion range or the repeats is where it is. So error codes, it also gives a few other examples, like backtracking is one of the most common ones where like you basically just undo your code until it starts working again. So you can find out what's wrong. Or what else you can do is you can comment out your new code and progressively uncomment your code until you find out what's wrong. So these are just strategies and techniques that we've kind of gone through in class already, but once again, it's just in one document for you. We haven't talked about breakpoints. We probably won't till next year, but there is another way to be able to see what's wrong with your code. The reason why we don't do it till next year is because when next year the code is more complex, you may need an actual point to say stop at partway through the program so we can see what's going on. But for now, backtracking, using comments, those are kind of good ways to be able to debug for now. Mathematical operators, so this is what we went through recently. This is last week's work, the different mathematical operators that we can use. What is the difference between modulus and floor divide? All those examples are here if you need them, as well as an example of modulus. All that's there. And then we have our mathematical conditions, where you can say if one number equals another, one number not equals another, and greater than or equal to, less than or equal to, greater than or less than. They're all there as well for your conditional statements, your if statements. And then finally, last class we talked about variables, where we talked about how they store data. We talked about the different naming conventions and how camel case is the most common one. And then from there, we also talked about data types. This is slightly out of order, but data types where variables store specific data. So whether it's an integer, a string, or a floating point number or decimal number. So all of those are kind of like your formalized notes. That's everything you need to know for this unit. When it comes to your unit exam, you do have 5 multiple choice questions and then like the program that you have to write. The 5 multiple choice questions, some of them are about Reebor's world itself, and then some are directly like from some of the notes here, or like things that we've been talking about, like I can't really specifically say, but like things that have been continuous, like what IPO means, what it does, how do we identify it into our programming. So things like that all kind of need to be put together. So with that, that's kind of like our notes for everything for this particular unit. So it's a nice summary for you for everything that we specifically learned in this unit. But just like with many of your other courses, it builds on things from last unit. So things like IPO, things like planning, all those things come back in this particular course as well. Okay. Any questions about any of the notes or any of the things that we've gone through in class? right before class started, I did add this assignment to Google Classroom. So this is, now that we're done notes, so this is your summative assessment. We've been working on Reebor's World for close to a month now, which seems like a lot of time, but remember, because we're year long, right, we see each other every other day, it just seems longer. So we've gone through quite a bit of content in order to do programming with Reebor, from moving him, from making subroutines, from doing conditional statements, and even having him remember by storing variables. So this summative assignment, this is your opportunity to show me what you know when it comes to being able to program Reebor. So your goal, and this comes back to this idea of addition, is that we want to teach Reebor how to do addition in this particular example. It's not calibrated. Okay, so in this example, where on my screen it shows 27 plus 58, in the actual file, I believe now the actual file is 58 plus 27. But the main part of it is that you want to be able to teach Reebor how to add. So when we look at this world, which is also attached to the classroom, it's just 58 and 27 that needs to be added together, with the caveat that when you do this, you want to also be mindful of the columns, where our 8 and our 7 are in our ones column, our 5 and our 2 are in our tens column, and then we have a hundreds column and a thousand column. So to be able to keep all of your digits separate. When it comes to this particular program, you're required is to get Reebor to add these two numbers together as the bare minimum. If you want to be able to get your full marks though, I should be able to choose any two random numbers between 1 and 99, and Reebor is going to be able to successfully add those two numbers together. So whether it is 1 plus 1, 99 plus 99, or any combination in between, Reebor should be able to successfully add them together to get your full marks. So going back to the document to talk about like what the expectations are. So this is the final view of where the program should look, where in addition to adding the numbers in such a way so that the stars display our final information without destroying our old information, there's this line, this equal sign line that's built with walls. And Reebor is on the right side, but if he's on the left side too, that's completely fine. I just want Reebor out of the way of the final number, okay? So if he's on the right side, if he's here, it doesn't matter as long as I can see the number easily. That's the important part of this particular final view. Also, when you're doing it, you're going to get that Reebor is in the wrong position as an error. Ignore that error. I think when I first made it, I wanted Reebor in a very specific spot. It's not as important anymore, as long as you just get him to add appropriately. What are some additional requirements? We spent a day doing flowcharting. Not a lot of you actually submitted a flowchart. I gave you feedback if you did. But part of your assignment is that you need to submit a flowchart for this project. So some of the things that I did give feedback on is that when you're doing your flowchart, make sure that you are not just recreating your program in flowchart form. A lot of people will do their flowchart last, just like you do your planning last when you write an essay, and it causes problems where you just kind of start writing your essay in your outline. And it's the same thing here. You don't want to be writing your program in your flowchart. Ideally, I'd like to say that you start your flowchart first. A lot of you are going to ignore that and just do it last. But hopefully one day you see the value of starting it first. So that has to be done. I prefer it done through draw.io, but you're not going to lose marks if you decide to do it on paper and then take a photo of it and then upload it to your assignment. That's also acceptable as well. But I prefer that you do it in draw.io since you have the day to work on that particular program. It also has to be able to add, the program, like I said, has to add any two 1 or 2 digit numbers together, and then it has to follow IPO structure as close as possible. So what I mean by that is that when you take a look at your actual program, that we have 4 different squares that has information in it. So what a lot of people like to do is that they like to just work in the ones column, find an answer, and then work on the tens column, finds an answer, and then potentially do a hundreds column if they need to. And the problem with that is that then you're only taking part of your inputs first, and then part of your inputs next, after you've done some processing. So you are doing IPO, but you are kind of doing it twice. So my recommendation for this particular assignment is to collect all the stars first, and then that will already set you up for IPO because you're doing all your inputs into Reebor first. And then you do your calculations, your processing, and then you display everything at the very end. And that will naturally follow IPO through that particular messaging. So it has to be able to follow IPO, as well as you have to organize it effectively with headings and comments so that I'm able to understand your code. This also includes variable names. So the next point, make sure that your subroutines and your variable names are descriptive. I don't want to see things like x is equal to x plus 5, right? Because I don't know what that x is. So you want to be descriptive with what your variable names are. And then of course use comments, headings, and for your headings and for explanation of your code where necessary. I don't need a line of comments for every single code, but I do need, if you're going to have a block that does one particular thing, give it a heading. So that's all the requirements of the assignment. Please note that in here, there's nothing that explicitly says that you have to do a subroutine. So you can't get marks off if you don't do a subroutine. There also is nothing explicitly here that says that you have to do conditional statements, because those are tested in next unit's unit. However, you'll probably find some of the things will work better if you use conditional statements or while statements in order to get your program done. Okay, this next section, I'm going to pause and say it's really important that I need everyone's attention for this section, because we're going to talk a little bit about academic honesty and integrity. We're at a school which, above many things, prioritizes the ability to collaborate. This is why you're put into groups. This is also why in other classes you're not always forever just taking down notes. We want you to talk with each other. But there is a fine line between what is okay to talk with each other and what is not okay to talk with each other, because then you're doing someone else's work, which is ultimately cheating, right? And it's good to learn this lesson here in high school, because here, the consequences are not as dire as somewhere like post-secondary, where your consequences at post-secondary could be as drastic as getting kicked out of the course with no refunds, or getting kicked out of the university, right? So just be aware that, I'm not saying this to scare you, but it's really here to protect you so that you're able to succeed not just at this school, but in the future. So what are some clear guidelines I'm giving you about your work? Because it is being assessed as your work. So first thing, don't share your programming code. So what I mean by that is if you're done, or if you're mostly done, and someone is asking for help, all you're going to do is let me just email you my .py file. Please don't share your code, because then you don't know, as a marker, then I don't know whose code is whose, right? It becomes an issue where both get penalized for copying. As well as, I've seen it where someone has copied someone else's code and they've changed variable names and header names and everything, but it still basically looks the same code. So at the end of the day, it is something that is quite easily identifiable if two people are using the same code. So don't do anything like that. You want to be able to still see other people's code. So going to the second point, you can definitely look at people's code if they're having difficulties and they need some help. So if the student right beside you, hopefully you know their name, is really frustrated, they can't quite figure out something, they finally are like, hey, can you help me with this? It's completely fine to look at their code, right? And then be like, oh yeah, you have an error here, here, and here. Just like in English, when you're writing an essay, it's completely fine to peer edit when you're reading someone else's essay and be like, oh, you missed a comma here, or so on and so forth. That's fine, right? However, what's not okay is being like, okay, I don't know what I'm doing wrong. I'm just gonna go ahead and walk over. Oh look, Cole has the answer. Okay, now I'm good, and then like go back. That's definitely not an okay thing to do. To just like go walk around and be like, hey, you're a smart person. Let me just have a conversation with you so I can steal code. That's definitely not something that's okay, and that falls into number 3, where you don't want to be stealing someone else's code or copying it because, once again, it's not your work. Especially with programming, when we teach collaboration a lot, it's really hard to not copy, especially like in later years, but it is an important thing in your teaching and learning to be able to write code yourself. Because here's the thing, if you copy code for Reebor Does Addition and doesn't get caught, which would be kind of surprising, where it's going to come out of is going to be in your unit exam. Because in your unit exam, that's 1 day to write a program, and if you can't finish, or if like things look completely different from your take home, then now the conversation is, why is your multi-day assignment, your Reebor Does Addition, 100%, but you only scored 20% on your actual unit exam? So it becomes clear with that as well. So please make sure that you don't copy any other student's code. Also, if you are helping someone, right, please don't type code for them. And I say this as someone who is like, it's like, oh, like, you're helping a classmate and they're just like either typing too slow or not typing the right things, and you're like, oh, just move, let me type it for you. That's a definite no-no. The other thing that's a definite no-no, I hear some typing, can you please stop? The other definite no-no is like, okay, Mr. Zhang said I can't type for you, but type exactly this. DEF space, right? TURN underscore RIGHT open close bracket colon. Like, don't tell them exactly what to write either, because that's the same thing as you typing it for them, okay? So these are just things that I'm telling you so that when you are collaborating with others, you have clear guidelines of what's okay and what's not. Because I still want you to talk to each other, but just not cheat off each other. So that's where this very last thing, where it says it's completely okay to talk about how you're solving the problem. One of the problems with this particular assignment is, how are you going to account for the fact that 8 plus 7 is going to give you 15, and you can't put all 15 stars in this one spot, right? Because then you're going to have 15 and a 7 here when really you need 85. So how do you solve that problem? You're like, oh, well, I did this with my stars, or oh, I checked my ones position by doing this, or oh, I like completely did it this way. That's completely fine to talk about, once again, as long as you're not sharing explicit code about it. So if I'm having a conversation with, once again, the person beside me, or the person on my other side, and hopefully I know their names, and it was like, oh, well, I would do it this way or this way, that's completely fine. Just don't go ahead and do the same code for each other, because then that will look very, very suspicious. So that's everything. Also, if you're uncertain of whether or not it's too much sharing or not, you can always come and ask me. That's completely fine. Okay, I'm not here to like tell you what you can and can't do at the very end. If you're like, hey, the student wants me to do this, is that okay? I'd be like, yes, it's fine, or no, that's a little bit too much sharing. So you can definitely ask as well. Because at the end of the day, right, if you allow someone to cheat off you, you're responsible, just as responsible as the student cheating off you. And I can say this out of experience that in junior high, I did not study for a vocabulary exam, and the person beside me also did not study for the vocabulary exam. So I just let him copy off me, even though I had wrong answers. But because they were both wrong and both the same, we both got caught and we both got in trouble. Even though, like, I just like, oh, like, I'm just gonna like leave it open, and like clearly I can see him copying off me. I don't really care, and I also got in trouble for it. So just be aware that, like, even if you just let someone copy off you, then you're also an accomplice to the crime. So be aware of that. Okay, so with that all being said, it's a lot of stuff to get us to the actual marking cell. I know I've been talking a lot. I'm trying to finish quickly so that we can actually start programming and not listening to an old guy talk a lot. So talking about the marking scale. So your total assignment is out of 12 points. It's broken down into 3 sections. The first section is your flow chart with 2 points. Then there is your source code. This is worth 8.5 points. Actually, sorry, this is only worth 8 points in this one, so 8 points. So when it comes to your source code, if you just give me a program that adds 75, 78, and if you give me a program that only adds 58 and 27, you're going to get 6 out of 8 total points for your source code. Right? So it can only do those 2 given numbers, and it can't do anything else that I throw at it, 6 out of 8. Okay? If your program can add any 2 numbers between 1 and 99, so 1 plus 1 to 99 plus 99, anything in between, you're going to get 7 out of 8. The final way to get that one point at the very end, and please make note that you don't have to make the program do this. You do not have to make your program multiply or subtract. However, the program code should be structured in such a way that in order to add that functionality, so if I wanted to switch between adding and subtracting, I should only have to change a couple lines, right? And even in those couple lines, I probably only need to change a symbol, maybe another symbol or 2. So that kind of gives you the hint of what I'm looking for. But when it comes to that 8.0, when I go through your code, if I need to change it to subtraction, I should just change a line or 2. And some students like to be explicit. They're like, Mr. Zhang changed this line to, and like this is the change. Some people, like if you just leave it the way it is and I can find that line, or those 2 lines, then that's good enough. And then you'll get that 8 out of 8, okay? So if you have been struggling or like you don't want to really use the if statements and so on, you can still just add 58 and 27 and get 6 out of 8 in this section. But it's up to you. Chances are you'll have more time to at least try for 7 out of 8 or 8 out of 8. I should also probably go the other way down, where if you submit a program that doesn't function, so it can add 58 and 27, but some of it is working properly, you'll get 5 out of 8. 4 is that it doesn't work, but you submitted something that has some things that work. And then 3 is that you just didn't submit anything, which is really rare because on the last day I always ask everyone to submit something. And then finally, additional marks. So you get 0.5 for your source code being, once again, descriptive with comments, with the appropriate variable and subroutine names if you're using them, with the appropriate IPO method, so inputs first, then all your processing calculations, then your outputs. And then finally, appropriate communication attitude, time management. This is basically like saying, are you using your class time wisely? Right? Are you taking a 20-minute break? Right? Are you finishing on time? Or are you needing to take another week to get your work done? Right? That's really the question that this is answering. You can almost think about this question as if I was trying to like work for, like go to a job. Like, am I being a good employee? Am I getting there on time? Am I being productive while I'm there? Am I making sure all of my tasks are done? Right, that's going to be that. As well as things like, if you need help, are you asking the people around you? Or are you just like going straight to me, right? Because I also want you to be able to communicate with others. So there's 2 marks there. There's 8 marks for the actual source code, 2 marks for the flowchart, all out of 12. And that is basically the duration of the explanation of this particular program. So I'm just going to quickly pull up Google Classroom, and then you'll have half an hour to start working. But the other thing that I want to, okay, wrong. The final thing that I want to talk about just in Classroom is the assignment that I have uploaded. So in this particular assignment, what I have given you for the instructions, so once again, everything that we've gone through, this is the addition to the world file that you need to download. And then finally, because earlier this year I had to do an instructions video for my semester class, I kept that here anyways, in case you want to rewatch that. It's more succinct from what we're doing in class, but I'll upload today's anyways. But that just kind of summarizes the instructions as well for you, hopefully in less time than what we're doing right now. So if you do need that, that's there as well. And then when you're done your program, I do want you to upload your .py file and your image file of your flowchart to this assignment. We'll talk about that closer to the end. But apart from that, when we look at Reebor's world, so this is what you're trying to solve. There is an end image on the assignment. Is there any final questions about this assignment? Yeah, so when I'm testing, I'll test, like I will have like a random number. Here I can't tell you the number now, but there will be a random set. So this might say like 15 and 3 could be what gets added, okay? So it could be any number from 1 to 99, and I'll be removing and adding stars as necessary, okay? There's a question here, and then I'll get to yours.
Is there a way to display like a 0 star? Or
So that's a good question. What does 0 star mean?
It's just going to be empty.
It should just be empty because there's no stars, okay? And then a question.
So we put like any star here, just to see if
So like you can like edit the world and put in different numbers in your testing. For sure, do that as needed, okay? Anything else? I'm just also going to remind you, it may be wise to look at some of our old programming code as well, so that to help you kind of get ideas as well. We did do an addition, we did do some variables, so those things may help you out with this particular assignment. If there's no other questions, I'm finally done talking for today. I promise next class I'll talk considerably less. You can get started on this particular assignment. Thank you.